Hello students, today we will study how to calculate the resistance of an unknown material of wire. Now we are using this piece of wire of which we will calculate the resistance using the principle of Ohm's law. What we have studied in Ohm's law. According to Ohm's law, the current flowing through the resistor is directly proportional to potential difference across it, or we can say current flowing through any circuit element is directly proportional to potential difference across it, but the resistance must be constant. Now to obtain this condition, as we know, resistance of any wire varies with temperature. So the material we are using is having very low temperature coefficient of resistivity. It is actually constant in, but what will be its resistance we will calculate using the Ohm's law. So how to connect these circuit element? What are these circuit element? Let me familiarize you. It is the battery eliminator. This is rheostat. It is a kind of resistance whose resistance can be varied by moving this slider left or right. By varying its resistance, we can increase or decrease the potential difference, potential drop across the various circuit element connected in the series or connected in any connection. Now these are the two measuring devices. One is voltmeter and another is ammeter. Okay, today we will also study how to determine the least count of analogous measuring devices, analogous meter. These are analog meter. To this analog meter we have to determine the one division of it will be equal to how much volt or how much ammeter. And it is a plug key. It acts as a switch. When it is inserted, it acts as a switch on condition. When I take it out, it is called plug out. It acts as a switch off condition. This will act as a socket. Okay, across it we will connect our unknown piece of wire, a wire of which resistance is to be determined. So I will connect it on this, across this. Now how to connect these circuit element in a circuit? Just to follow this circuit diagram, how these devices are connected, just connect all the device in the same manner, we will obtain our circuit. And the basic idea of this is all the devices are connected in series except voltmeter. So keep the voltmeter aside and connect all the devices in series connection. And we have to connect the voltmeter across parallel to the resistor, that means this wire. We will deal with this later on. So how to connect this? Now in series, one end of one device is connected to another end of another device. Now just follow this condition. We are having this battery eliminator, its voltage is fixed on 4 volt. Now its one end is connected to the rheostat. Rheostat are having 3 terminals, one on slider and 2 terminals are here. Now connect one end on the slider and another end on this terminal. So I have connect one end of the battery eliminator to the rheostat. Now one end of the rheostat, means this end of the rheostat is connected to ammeter. Now this end of ammeter will be connected to the socket, across which I will connect this piece of wire of which resistance is to be determined. So just connect them. I am joining them together because they are to be connected on a same terminal. It will be easy for me to connect them. Okay, now I have connected it. So one end is connected. Now one more thing, I have to connect this resistor in series. So it need to be connected across here. So do it very carefully. The wire must be connected properly. There must not be any loose connection. Otherwise we have to check it later on. So do it carefully to perform the experiment in a one. Now as the series connection says, just connect one end of any circuit element to the other. Now we are connecting the key. I am plugging it out. Okay. These all elements are now connected across series, but the circuit is still open as one end of this plug key is open and one end of this battery eliminator is also open. Now take another connecting wire and connect it to the another terminal, second terminal of battery eliminator, and the another end to the plug key. Now I am inserting the plug key. It will act as a switch on condition. All the devices are connected in series now. The one device that will provide us the potential difference is our voltmeter. So all the elements are connected in series. I have told except the voltmeter, so I have kept the voltmeter aside and connected all the circuit element in series. Now I would require the two pieces of wire. I am using this big piece of wire and making its two halves. Or I can use the other. Okay. Now connect it across the parallel. What is the basic of parallel? In parallel connection, the both ends, as this unknown resistance of wire having this end and this end, both of these end will be connected across this. Okay? Okay. So just connect the connecting wire across the voltmeter. And the two ends that are left, they need to be connected to the unknown resistor. To the unknown resistor. It takes a bit of time, but keep patience and watch it carefully so that you can perform it easily. Now the end which is left now, join this to the other end of resistance wire. Now my circuit is completed. Now how to verify this is in parallel connection? In parallel connection, what happens? Both the two ends are connected across both the two end of this device and this device are common. It is connected to the negative terminal, it is connected to the positive terminal. So it will provide what is the potential difference across this socket. Now we are connecting the resistance wire on the socket, so it will provide the resistance of this unknown resistance wire. Now what we have to do, we have to just switch on the battery eliminator. As I switch on the battery eliminator, then I must check all the okay. Now as all the devices are connected in a circuit, all circuit elements are connected in a circuit, now we must check whether our connection is correct or not. Means when I slide this slider, when I move this slider of rheostat, there must be variation in this ammeter and voltmeter. This analog device, the needle of it must move. So do it very slightly. I am doing it very slightly because I have to take at least 3 readings. There is no variation, no movement in the needle. Keep on sliding. No, now we are observing a little movement in the needle of ammeter. You can clearly observe here. I am just keeping it a bit at a bit of height. After this there must be some movement. Okay, now the needle is moving. So this one. Okay, as this slider has reached here, the reading of ammeter is around between 0 to 0.5 ampere. I cannot say it exactly, and the voltmeter is showing nothing. In case if we are moving this slider, the ammeter is showing deflection towards the positive quantity. In any case, if any of the device is showing deflection in opposite direction, that means you have connected the polarity in reverse condition. So just change the polarity. Okay. Now as I am sliding this slider, we are obtaining the reading in ammeter. Do it very gradually. And what is the corresponding value of voltmeter? Now we are not able to exactly tell what is the value of ammeter and voltmeter because these are the analog device, and analog device are having a least count. Least count means what is the value of one division of this analog meter. Now how to calculate its least count? Now to calculate the least count, just observe the 2 division on which number is written. Now the first division is 0 and the next consecutive division on which number is written is 0.5, and this ammeter is showing the reading in ammeter. So I will take it as a range. I can take 0 to 3 also as a range, because then in that case I have to calculate all the division between this. That will become a very tedious task. So I am doing what? I am taking 0 to 0.5 as my range, and number of division between it will act as the total number of division between my range. So this need to be done very carefully. I am observing 10 division between 0 to 0.5. So for the ammeter the range is from 0 to 0.5. So 0.5 minus 0, this will give me the range, that is 0.5. How many divisions are there between these two numbered division? There are 10 division. So my least count will be range 0.5 divided by the total number of division between these two numbered values, numbered division. So least count comes out 0.05 ampere. It's mean that one division on this ammeter is equal to 0.5 amperes. Similarly, we will calculate the least count of voltmeter. Now my voltmeter is similar to the ammeter, it is having a same least count. You can also observe this. It is starting from 0. The next consecutive division on which number is written is 0.5 and total number division are 10. So I can take the least count of voltmeter equal to least count of my ammeter. Its range is 0.5. Total number of division on it between these division is 10. So 0.05 is the least count for this voltmeter. Now as we have obtained the least count, so we can proceed in our experiment. Now at this position of slider, my ammeter is showing at the 5th division. So it is showing 5th division, 5 division is equal to how much ampere? Use the least count concept. 1 division is equal to 0.5 ampere. So 5 division is equal to 5 multiply the value of 1 division, that is my least count, 5 multiplied by 0.05 ampere. It will be equal to 0.25 ampere. I have obtained one value of current at this position. Similarly, we will take the 2 more readings to obtain the mean resistance. Now, what is the potential difference across it? The voltmeter is showing 1 division. Voltmeter is showing 1 division. 1 division is actually equal to least count, that is 0.05 volt. We have obtained both this quantity. According to Ohm's law, resistance across any device is equal to potential difference upon current. So what is the potential difference at this condition? It is voltage is 0.05 and the current is 0.25 amperes. Remove the decimals, we will get 1/5 ohms. Okay, for this condition we are obtaining resistance as 1/5. Similarly, I am calculating one more reading, another reading at the another position of this rheostat. Now gradually move this rheostat because it will show a very rapid deflections. I am adjusting it at 0.5. I am trying to adjust it. Maybe okay, whatever reading I am obtaining at this position of this rheostat, we are getting reading on ammeter as it is 12th division. The ammeter is showing 12th division because up to 0.5 there are 10 division, and this needle is coinciding with the next to 2 division, that means 12th division. So reading of ammeter is 12 division. 12 division is equal to how much? 12 multiplied by 0.05. It is 0.6 ampere. I can say 0.60 ampere. And what is the value our voltmeter is showing? Voltmeter is showing the 3rd division. 3rd division is shown on voltmeter. 1 division is 0.5, so 3 division is equal to 0.15 volt. Now calculate the resistance. Resistance comes out 0.60 divided by 0.15. Oh, we have taken the readings wrong here. Potential difference is 0.15 and current is 0.60. I think 15 forza, it is 1/4. We will not obtain an exact reading because it is an experiment. There are some manual errors also. I may take one division less or one division more because of the parallax error, as whatever I am reading, okay, there may be a little bit of errors. Now what is the mean value? So the mean resistance is, I have taken 2 readings, R1 plus R2. This must be divided by 2. What are this? Can I take this quantity in decimals? In decimal it is 0.2. In decimal it is 0.25. So 0.2 plus 0.25 divided by 2. It is equal to 0.45 divided by 2. What reading it is showing? 0.22. Approximate 0.22. We can say ohms. It is more an approximate near. So it is the resistance of this piece of wire. Now we can verify with the help of graph also. We can plot a graph, we will obtain a nearly straight line. It will not be exactly straight line, because more and more reading we will take, it will become more and more accurate. I have taken 2. Similarly, we can take at least 4 to 5 reading to obtain a value that is near to the actual one. I hope you have understand.